Hello my dear students, happy morning to you all. Welcome back to the channel. If you are preparing for your examination, especially in case of NEET and MSET, say maximum both are similar problems over here. The difference only you can see in J mains. See, in this presentation is just for you those who are preparing for the examinations. Now you are brush up your concepts on mutual inductions. You are in the right place now. Today we are going to the concepts on mutual inductions, especially in case of electromagnetism. The mutual induction is an important concept here. I'll be going through some of the careful selected old question paper problems that has been frequently asked in case of your NEET and MSET, both the cases here. Over the years they have keep on asking some of the questions over here. We are breaking through all the problems step by step and explain the logic behind each solutions over here, and I'm going to highlight some of the key points that you need to remember. So grab your notebook and stay focused. Let masters in mutual inductions together. Let's get started. The mutual induction old question paper problem. Welcome you once again. Okay. Coming to the first problem, these are all a old question paper problem here. Two circuits having coefficient of mutual induction. So mutual induction M value they have given. Average EMF induced in the secondary coil by changing the current in the primary. So 0 to 20 ampere, and the changing time is 0.06 second. Now, what they are asking in this case, they are asking about induced EMF. See, according to Faraday's law of electromagnetic induction, this one induced EMF E is equal to M into di divided by dt here. Now, this one M value they have given, that is 0.09 into current. Changing current here is final minus initial, that is 20 to 0 here, and whole divided by dt value they have given 0.006 second. Now you just substitute the value. This one 9 divided by 100, that is nothing but 0.09, and this one here is 20, and this one you can mention like 66 divided by 1000 here. See, from this one you can cancel this one for 5 times. Now see, 9 divided by 5 into this one here is 1000 and divided by 6. We just cancel it for the third table. So what you are going to have here is 3 into 1000 whole divided by 10. So this one will be cancelled here. So what you are going to have here is 300 volts. So the induced EMF in the secondary coil by changing the current in the primary coil. So answer here is 300 volt. Similar problem we have seen in the previous presentation. See, a pair of adjacent coil has a mutual inductance. They have given M value. If the current is changes from 0 to 20 ampere in 0.5 second, what is the flux changes? See here, they are not asking the previous question. They are asked about EMF. EMF means the previous question you can use the same one. But here, what they are asking here is flux changes. Now we just find out the relation. Similar concept, nothing much difference here. See, what I'm going to mention here is, see, flux changes. See here, uh, flux changing a flux is mainly rate of change of flux, which is due to producing your induced EMF in the primary coil. This one I have mentioned already. See, there are two coils over here. This is a primary and this is about the secondary coil. See, whenever the current is passing through the primary coil, it changes the rate of change of the current, which produce the induced EMF here. See, this will produce the change rate of change of current that will produce your changing flux on the primary coil. This changing flux, which is linked to the secondary coil, that will produce a changing current in the secondary coil, which is recorded in the galvanometer. You can understand here. It shows a deflection in the secondary coil. This concept from here, E is equal to d phi by dt. This is the first question, and the second one here, the previous one, the rate, this one induced EMF is directly proportional to changing current, that is di by dt, and the proportionality constant we are going to remove, that is M here. M is about proportionality constant. We call it as a mutual inductance. From equation 1 and 2, what you are going to have here is d pi divided by dt. That one will be equal to M into di divided by dt here. In all the cases, the changing current will be the same. So from here, from here what you are going to mention here is d phi equal to m into di. So m value already they are given, that is 1.5 Henry here, and the current here is 20 minus 0 ampere. So what you are having here is 1.5 into 20, that is about see here, that is 31 cipher you just mentioned here in this case. So this one what you are going to have here is 0.5 seconds. If you mention this one, 30 Weber. So answer in this case here is 30 Weber. Previous question paper again, with the decreasing of current in the primary coil, so 2 ampere to 0 in 0.01 second. So changing current and changing time they have given, and EMF generated here is 1000 volt. So what they are asking, mutual induction. See, as usual the same formula here. Mutual induction formula here is E is equal to M into di divided by dt here. Now from this one what they are asking, m value. M here is E divided by di whole divided by dt. Now from this one E value here is 1000 volt whole divided by di. Changing current here is 2 ampere. So 2 minus 0 is 0, and a whole divided by 2 minus 0 is 2, and a whole divided by 0.01. Again from this one 1000 into 0.01 whole divided by 2 here. See, from this one what you are going to have here is 10 divided by 2, that is 5 Henry. So mutual induction in this case, answer here is 5 Henry. So this one sometimes the current here is you may have a minus 2 here, right? See this one, in that case you may have a final minus initial, that is 2 minus 0 minus 2, you may have a 2, but you are going to concentrate only the magnitude of the change in current. So you are going to consider only positive values. Problem, this is concept oriented. Even the previous year question paper also they asked the direct questions, theoretical part of questions. The coefficient of mutual induction between the two coils, it depends on, see here, medium between the coils and separation between the coil and orientation of the coil, all the things. This is the concept here. I will show you this one. See this one, geometry of the two circuits depends on the whether it is a circular or even a square. According to this it may vary. And mutual induction which increases by increasing number of turns, that's what see here. This one you can mention here, mutual induction M is equal to, you can see the formula. M here is mu naught mu r n1 n2 and area A, and length here is L. Even sometimes you can mention this one pi r square. For in case of a circle you can mention as pi r square. Suppose in case of square you can mention like a length into breadth. According to this geometry it may vary here. So the first one is about depends on the geometry of the circuit. Even the mutual induction of a inductance here, by increasing the number of turns, even that is directly proportional over here. And yeah, and this one with mutual induction decreases with increasing the distance between, so the length also it will be depends on this one. And mutual induction increases by increasing the cross sectional area. See the cross sectional area and the length they are mentioned here, and the number of medium, number of turns, and even the permeability mu r also. So in all these cases, even see the angle between the axis 0 degree and 90 degree perpendicular to the axis, it may vary here. In all the cases it is depends over here. So in that case answer here is all this one. This is about the mutual induction. Even sometimes you have to know about this self induction also. Self induction, even geometry of the coil, number of turns and the length, the area of cross section, permeability, all are similar. Even additional here is nature of the material of the core of the solenoid, that will also important in case of self induction. You need to remember this one also in addition. Next one, two coil, 10 turns each are arranged such that the mutual induction between them here is 150 millihenry. The magnetic flux linked to one coil, when a current of 2 ampere current will flow in another coil. See this one we have seen the first problem. See, hope you remember how we have made the formulas here. E is equal to d pi divided by dt here. This is equation number 1. Even the same EMF induced in the coil. This is mainly depends on the rate of change of current. That one we can mention here. M into di divided by dt. This is equation number 2 here. From equation 1 and 2 we can mention this one. D pi, that is about the changing flux in one coil. It's mainly depend on, this is first equation, changing flux in one coil, this is first coil here, and the magnetic induction, the secondary coil, mutual induction, not magnetic induction, mutual induction, M into di divided by dt here. So changing time on both the coil will be the same. So from here pi is equal to M into I here, because if you integrate this one on either side, d phi will become only pi and di will become only I. And at the same time they have mentioned here number of turns in the primary coil, so that you can mention in this case from here pi is equal to, so what you are going to have here is pi is equal to m I divided by number of turns. M here is what they have given, that is 150 millihenry, that means 10 power minus 3 henry, and current in this case they have given 2, and whole divided by number of turns here is 10. So you just cancel here. So what you are having here is 15 into 2, that is 30 into 10 power minus 3 Weber. So answer in this case, even sometimes they will give you uh, zero point 0.3 Weber. In any one will be the answer. One, this is little important. They are frequently asked question. Two coaxial coil are very close to each other, and the mutual induction here is 5 millihenry. If the current of 50 sine omega t, this one I equal to I naught sine omega t, the current is passed through one coil, then the peak value of induced EMF, peak value see here. For in case of AC current, you can mention this one. The current I is equal to I naught sin omega t. So I naught here is peak current. Similar here, E is equal to, or even V is equal to E naught sin omega t, and the peak voltage here is E naught. Similar one from here, mutual induction or even a changing EMF E is equal to, what I'm going to have here is minus M into di divided by dt here. Already we know what they have given, the I value here is I is equal to 50. I naught is nothing but 50 here. Peak current sine of omega t here is 500 t. Now you just substitute the values here instead of I value. Minus of M here is they have given 5 millihenry, minus 5 into 10 power minus 3 henry, right? Into current here is d by dt of, we just substitute the value 50 sine of 500t. Now 50 is the constant term, you just take it outside. So 5 into 50 is there, and 10 power minus 3 is there, and you just put the negative values here. And sine omega t, if you differentiate, what you are having here is cos of 500t. Cos omega t into omega here is, you can mention here, that is 500 again. Now this 2 cipher and this 1 cipher, it will be cancelled over here. So what you are having here is minus 1 5, 2 5, and 3 5 is there, that is minus 125 cos 500 t. That one will be equal to E. This one you just compare with this equation. So from here E naught is equal to, or even E naught is equal to 125. So answer in this case 125 volt. This is similar like a previous one. See, they have given here omega value separately, but previous one they have given in this equation only. That's all difference. See, in the case mutual induction value they have given, and even the current changes they have given in equation form. Peak value, I naught value they have given, and omega value they have given. One important highlight point we need to understand here is maximum value of EMF. See here, maximum value in that case. See, I just tell you here. Now, see, in this case, EMF is equal to this one. EMF E is equal to M into di divided by dt. Now, from this one, here you are having minus is there. Say, from here, minus M into d by dt of I value here is I naught cos omega t. Now from this one, if you differentiate here, so what you are having here is m into this one I naught will be there. So I naught cos omega t. If you differentiate, what you are having here is sin omega t, that is minus sine into omega here. Now from this one, minus minus will be cancelled here. So m into I naught sin omega t into omega. Right. Now substitute all the values in this case. M value here is 5 milli into 5 into 10 power minus 3, and I naught value here is 10. Omega value here is 100 pi into sin omega t. See this one, sin omega t, I just mentioned here, sin omega t will be equal to 1. How this one will be equal to 1, I will tell you. Now from this one, if you cancel here, so 5 into 10 power minus 3, and this 1000 will go, so 5 pi into sin omega t, that one will be equal to 1. Say for example, in case of sine waves here is sine 0. See this one here is 0, this is pi by 2, and this one here is pi. See all the case pi by 2, pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2 here, and next one here is 4 pi by 2, 4 pi by 2 here is 2 pi. Simple, this one here is 2 pi. See pi by 2, pi, 3 pi by 2, and 2 pi here. See sine wave, sine 0 is 0, sine 90 here is 1, sine pi is 0 again, sine 270 is minus 1, next sine 2 pi, 3 pi by 2 is minus 1, sine 2 pi is 0. See in this case, maximum value, see here, maximum value at what time you are getting here is, see this one, at a maximum value of 1 only during 0 and pi. In all the cases, sine 0 or even sine pi, sine of pi, in all the cases that is 1. That's what they have given, the maximum value of EMF. So what I'm going to mention here is 5 pi into maximum value here is 1. So answer here is 5 pi. So answer in this case, this question is concept oriented. Two circular coils can be arranged in any of these three situations in the figure. The mutual inductions will be where it will be maximum, whether A, B or C. See, for in this case, the mutual induction, what is the main concept behind here is, so the mutual induction means, see here, this is about the flux linkage between the two coils. See, what is going to happen here is mutual induction. What do you mean by mutual induction? Again, I just mentioned here, when a current is passing through one coil, it produces a changing flux around the coil, right? This changing flux is linked to another coil here. This one I just mentioned here, another coil. This changing flux is induced EMF. That induced EMF you can measure with the help of a galvanometer over here. So this is mainly depends on the current which is passing to one coil, and another one, the flux linkage between the two coil is the main reason. So that the mutual inductions in this case, again I just mentioned here, the mutual induction between two coils, this one or any of this arrangement, is mainly depend on the flux linkage. Now this one, what you mean by flux linkage here is, the flux will be linked in one coil to the another coil. In all the cases I just mentioned here, in all these three cases, how the flux linkage will be there. See here, see this one, it has been arranged like this. So what is going to happen here is, so the flux linkage will be like this, right? Now like this it will be produced over here, similar like this. So you just consider in this case, similar like this, the link will be produced. Similar in this coil also, I just mentioned here. Now similar here also. See the flux linkage between these two coils. See in this one. Similar like this, you just consider here, the flux linkage between here is, this will be like this. Similar here, this one will be like this, right? Now you just consider in this case, see here, in this case it will be like this, right? Now compare this to this one. See here, I just mentioned here, in all the cases, how about the flux linkage over here? See this one, this will be produced like here. See, now in that case, what is going to happen here is, compared to all these three cases where the linkage, flux linkage means this one will be overlapped to the another coil flex, that is we call it as linkage over here. In all the three cases where the flux linkage, see here in this case, see in all of this area, see only to this area only it is maximum here, and in this one, see one is like this, another one is like this concept here. Even in this case also it will be little minimum here, but only in the case of this is maximum over here. So flux linkage is maximum in this case. So answer, this is quite interesting and important, frequently asked question. A straight solenoid, 50 turns per centimeter. See here, this one here is turns per centimeter. And another secondary coil, that is 200 turns. Area of cross section 4 centimeter. They are asking about mutual induction. See this one, what is the formula for mutual induction? First one I just mentioned here, M is equal to mu naught. So N1, N2, area. That's all. So this is about the mutual inductions over here. Now you just substitute all the values. What you mean by N1, what you mean by N2, I just mentioned here. See this one, N1 here is 50 turns per 50 turns per centimeter. Now you just convert here, that is 50 into divided by turn here is 10 power minus 2 meter here. So what you are going to have again, that is 5000 turns per meter. Now next one here, N2 value already they have given, that is 200 turns, total 200 turns, and the area of cross section what they have given, A is equal to 4 centimeter square. Now you can mention here 4 centimeter square here is 4 into 10 power minus 4 meter square. Right, now substitute all the values here. So M is equal to mu naught value here is 4 pi into 10 power minus 7 here, and the next one here is N1 value, that is 5000 here, and N2 value here is 200, and area here is 4 into 10 power minus 4. Now in this case I just simplify this equation here. This one 4 pi into 4, so what you are having here is 16 pi is there. Next one 10 power minus 7 and 10 power minus 4, what you are having here is 10 power minus 11 is there, and 5 into 2 10 is there, and this 3 and this 2 10 power 5 is 10 power 6 is there. Now you just cancel it from here. So what you are having here is 16 pi into 6 means 10 to the power of minus 5 is there. So here is 16 means 16 into 22 divided by 7 into 10 power minus 5. Once you cancel it here for in case of us, sorry, or else you can mention here 16 into 3.14 into 10 power minus 5. So what you are having here is 50 point, this one if you multiply over here, the 16 into 3 is around 48, you just multiply here, 50.26 into 10 power minus 5 will be there, or else M is equal to 5.026 into 10 power minus 5, sorry 10 power minus 4 Henry. So answer in this case. The next important problem, yeah, long solenoid diameter they have given with the number of turns per meter they have given. At the center of the solenoid, a coil of 100 turns, a radius of 0.01 meter is placed with its axis coincide to the solenoid. See this one solenoid I just mentioned here. See one long solenoid here. So I just mentioned like this, one long solenoid which is having number of turns here is 2 into 10 power 4. See another one more solenoid they have mentioned here. See I just draw in a different color, which is placed at the center here. So this one which are going to place at the center. For this what they have given the number of turns in this case. See here that is 100 turns. So this one here is 100 turns, and here radius is equal to 0.01 meter, but in that case radius here is 0.1 meter. Now what they are asking in this one, the current in the solenoid, see here the current in the solenoid reduced at the constant rate from 0 to 4 ampere. See 4 ampere in 0.05 second. If the resistance of the coil R value they are given, so the total charge flowing through the coil at this time, so Q value they are asking here. Now in this case they are asking about Q value. First one, what is the magnetic field that will be produced at the center. So may be at the center of the solenoid. I just mentioned here, be at the center of solenoid. Solenoid here is B is equal to this one, you know here, that is mu naught n into I. Now the number of turns in this case, B value here is 4 pi into 10 power minus 7 into number of turns here is already they are given, that is 2 into 10 to the power 4, and the current value, that is 4. Right, now you just substitute here 4 into 2, so this one 16 into 2, 4 into 4, 6, 6 into 2, 32 into 10 power minus 3 Tesla. This is about the magnetic field. Now, next one, the flux is linked. See what is going to happen in the first case. The flux is linked to the secondary coil. So this one, I just mentioned here, magnetic flux linked to the secondary coil. See, magnetic flux linked through secondary coil. I just mentioned here, linked to the secondary coil here is, see, pi is equal to n into Pa. Now this one n value what they are given, that is already they are given, that is secondary coil 100 turns. B value already we found, that is 32 into 10 power minus 3, and the area here is pi r square, so pi into r value they are given, that is 0.01 square. Now you just simplify this equation here, so this is 100, so this one will be cancelled here, so 32 pi into 10 power minus 1 is there, and this one now you can mention here 1 divided by 10 to the power, see this one 0 point square means 0.0001, so how you can mention here is, so 0.1 divided by 1000 here. So from this one what you can going to have here is 32, already one more pi is there. This one here is they have given 32 pi, already what we found out here is, see this one here is, I'm sorry, I have mentioned here, this is 32 pi, and here also 32 pi, and one more pi also is there, so 32 pi square into this one 10 power minus 1 into 1 divided by 10 to the power 4, so what you are having here is 32 pi square into 10 to the power of minus 5. So what we got here is pi, that is linked to the secondary coil. Now next one, so what they are asking here is charge, total charge, right? So total charge here is Q is equal to this one here is del pi, that's what we got here, del phi divided by resistance here is R. See already we mentioned here, that is 32 pi square into 10 power minus 5 whole divided by R value they have given, that is 10 pi square, that is ohm resistance here, so 10 pi square here. Now you just cancel this one, so from here what you are going to have here is 32 into 10 power minus 6 is there. So 32 into 10 power minus 6. So what you can mention here is 32 microcoulomb. So answer in this case 32 microcoulomb. Thank you so much for your patient listening. If you found this video is helpful, don't forget to like, share and subscribe for more video like this. Next presentation will be on AC circuits, where we are going to see some of the important concept and important tips which is behind on this all the problems and shortcuts also. I'll see you on the next one. Thank you.